I'm Colin Brown.
I'm Mason Cipollini
This is Lab 11 Detectors.
for OPTI 380 under TA Aluminium.
In Part A, we first explored the difference between an avalanche photodiode and a large area silicon photodiode. On the oscilloscope, the photodiode signal can be seen on the top with the avalanche photodiode signal on the bottom. The APD shows a clear square wave with no decay characteristics, while the silicon photodiode shows exponential transition between high and low signals. We then adjusted the intensity of the LED such that the signal of the silicon photodiode had an SNR of 1 and was barely visible. The APD showed an SNR of 2 and was still easily readable. This is due to the much more rapid response of the APD. In Part A2, we characterized the response of a PIN photodiode. We found a linear response for the current and a logarithmic response for the voltage. When graphing the two against each other, we found a very low linear current response up to a 100 millivolt reading, after which the response is exponential. In Part A3, we characterized the response of a photoconductor. First, we observed the photodiode and drew a sketch from which we found a matching diagram. Using the description of the photodiode, we found the equation for voltage, where VA is the power supply voltage and R series is the series resistor voltage. We found a voltage response consistent with the equation. We found a linear current response, and as such, the current voltage response is simply the inverse of our voltage response. In Part A4, we measured the temporal characteristics of a PIN photodiode. To do this, we placed it under the black cloth with a strobe source and flashed it. We then observed the response on the oscilloscope. The reading on the left is with a parallel resistor, and the right is with no resistor. We found a pulse width of 0.98 milliseconds with the resistor and 8.2 milliseconds without.
For Part B1, we looked at the CMOS spectral response to visible and IR light. To do this, we first looked through the IR filter around the room and saw no visible change, which was expected. Then, a line card was mounted on a rail with a lens and camera, the card was illuminated with a lamp, and the camera was focused onto the lines using the ThorLab software. We captured images of the lines with and without the IR filter and saw no change. This was repeated with the IR LED in place of the lamp, which displayed a black image with the IR filter since the IR filter filtered the IR light. For Part B2, we used the IR camera to make observations of a pair of optical components imaging a hot soldering iron. We first found the focal length of the lens by placing it close to the soldering iron until the image was focused with the camera at infinity. We then calculated our z prime using a chosen distance z from the iron with the imaging equation, giving us the values needed to calculate the magnification m. We found the image with the camera and confirmed the magnification and z prime. A similar process would be repeated for the mirror, where both calculations were also physically verified.